So without further ado, I'm going to share my screen and just let me do it like this. Okay. Are you able to see the image that I am currently displaying? I think you should be. Yeah. All right. So I think I just want, there we go. So before we start with today's lecture, I want us to do a brief game. Some of you might know it. It's called a Music Box, but for the sake of the lecture, which is Introduction to API Testing, we're going to call it a sort of hybrid, a server Music Box, let's say. So what is the idea? We will provide the instructions in the live chat now. You can write in the live chat any item that comes to your mind. You can also write people, you can write countries, you can write whatever you want. The idea is you want to write, for example, I want to put, let's say, a laptop inside the server, or I want to take away a pencil from the server. So any item that you want to put inside or get from the server. And essentially, I will play the part of the server and I will tell you if you can or can't add that item. What is the challenge here for you? You can try and guess what is the idea behind the server and how the responses work. So try to guess which items you can and you can't add to the server. Does it make sense? Also, thank you, Ra, for providing the instructions in the chat. I see people are typing. If there are no questions, you can start writing items that you want to add or take away from the server, of course. And when you write them in the live chat, I will respond to you to let you know if you can or can't. And if you happen to figure out what is the idea, you're also free to share. If you understood how the server, let's say, works with all the requests that you send. Okay, so I see Francesco wrote add flower, and yes, Francesco, you can add flower to the server. That's very good. You can put that. No, Susan, you can write anything. It's not about hardware, so you can write anything. You can even, for example, Francesco wrote flower, so yeah. Okay, so Susan wrote sausage. Yes, you can add a sausage. Raya wrote add radio. Yes, indeed, you can add a radio to the server. Let's see. I see Juman wrote add jelly. Yes, that is okay. You can add a jelly to the server. I'm beginning to think most of the people know the game, but let's see what the others write down. Give it a bit more time. All right, so I see Pinu wrote add coffee. For this one, you can't add coffee, so that won't be possible. And then I see Francesco wrote add skissert, whatever that could be. You can't add that. I also see Susan wrote juice. You can't add juice to the server. So none of the last three are possible to be added. Inas wrote add sugar. You can't add sugar to the server. I see Susan wrote liquids in general. Susan, you can't add liquids. Francesco wrote was a word check. Okay, fair enough. I see Valentino said didn't understand the game. So basically, you just write any item you want to add to the server, anything that comes to mind, and I will let you know if you can add it or if you can't add it. So you just write whatever you want to add, anything. I see Bibi wrote pineapple. Bibi, you can't add a pineapple, unfortunately. All right, I see Daniel wrote add sound. No, you can't add sound, unfortunately. I will give a hint. I will also now, as a standalone person, say I would like to add an airplane, and me personally, I can add an airplane. That's a very good question, Valentina. If you can add anything, then why some stuff are not allowed? So there are rules specifically for individuals. So you can add, let's say, whatever comes to mind. You can try to add it, but it doesn't mean that I will accept it. So I see Jumana wrote add jeans, and yes, Jumana, you can add jeans. That's a very good thing that you wrote down, Francesco. We don't know the rules. Yeah. You're trying to guess what items you can add and what are the rules, basically. Why am I not allowing you? For example, I allowed Francesco to add flour, but I didn't allow him to add the item that was like scur something, so I didn't allow him to add that. I'll wait a few more minutes. You can add some more items. I see people are writing in the chat. And as I also mentioned, me personally, Angelo, I can add an airplane inside, so it is doable. Okay, Susan, you wrote down piano, and unfortunately, you can't add the piano. Unfortunately. Jixing wrote add bread. Unfortunately, you can't add bread as well. Susan wrote wardrobe. No, unfortunately, you can't add wardrobe. And Bibi, you can't add wine. Where rules can't be disclosed, are we investigating? No, well, you can try to guess why I'm not allowing something to be added and why something is allowed. Susan wrote chocolate. You can't add chocolate. And Samson, you can't add cash, unfortunately. More Daniel, you can't add a speaker as well. Sorry. Raya wrote add a mousepad, and Raya, you can't add a mousepad. I can give you a hint. For example, Susan, I think you can add a song, or you can add a, I would say, script. You can add a script. You, yeah, but I will tell you if you write, for example, add sound, I will say you can add sound. And Samson wrote code, so you can't add code. I see Francesco wrote, there's something going on with vowels. Well, it is connected, yeah, in a way. Susan wrote notes. No, you can't add notes, unfortunately. I'll give you one more thing. So I'm going to just use 3 names and I'm going to tell you what you can add with different letters. So I would say that Araya can add a, let's say, uh, can add a rope. So she can add a rope. Uh, Samson, you can add a, let's say, a song. You can add a song. And Valentina, you can add a, let's say, what is this? I choose a specific one. A violet flower. A violet flower, yeah. I see Francesco wrote the initial of the name can add an object with that initial. Yeah, that is correct. So wonderful. Yeah. Okay, so you already kind of got the idea what was the rule, let's say, of adding the items. So the idea was if you add an item that has the first initial of your name as its first initial, for example, my name is Angelo, and I say airplane, I am able to add it. But if I say basketball, then I am not able to add the basketball because it starts with B. And this what we just did here, although it's like a simple game, is in a way how APIs work. So as you noticed, most of you did not have any idea of what's happening or why I'm not allowing something and I'm allowing other parts. And that is because there was this rule in place for the items. And although you can understand how you can, for example, send and receive a request or response, you still don't know what's going on behind the box. And that's essentially what we will be talking and discussing today regarding introduction to API testing and APIs in general. So first, thank you all for taking part in this brief exercise. I'm now just going to move to the before we begin section. And what is an API to kick it off? Well, an API is something that allows different software systems to communicate with one another. So essentially, it allows communication between different applications and application systems, and it also provides some kind of operations that you can use as a developer or tester. Now, before I move on to the next section, I want to ask, do some of you want to share an example of how you have interacted with an API? You can write anything that comes to mind. We will discuss, of course, in more detail how the APIs work and everything. But just from this brief overview and definition, do you think that you've ever had the option to work with an API, let's say? And there are no wrong answers. So you'll find that you've definitely all of you have used one API at least one point. So weather checking in the phone, wonderful, Bino. Yeah, yeah, correct. The weather app uses an API to see to add the data for what's the weather going to be like, sunny or the winds. So all of this data is from there. Using Slack for chat, wonderful, Linus. Yeah, perfect. It is what we're using right now, and it's a great example. App for diesel prices. Yeah, yeah, wonderful, Susan. That's also correct. So that's another wonderful example. I see more people are typing. Stock market, yeah. I mean, Samsung, that's wonderful. That's even more complex, but yeah, it's definitely present in stock market, and you can see it connecting with some maybe analytic pages. Google Map for route, yeah, wonderful. It's very good. Yeah. So essentially, we can see that a majority, even I would say, even now, of us have used some kind of API at one point. At least, even when we have been logging into some accounts, we're using an API effectively. So um, that's wonderful to note. And I wanted to ask one more thing. I wanted to ask, have you ever noticed, so a bit moving to the second question, have you ever noticed some kind of bug that you think is related to the API? Have you ever noticed that when using any of these applications? Hey, Katerzyna, no worries. Glad to have you here with us. I can share one example with one bug that I had noticed, and it might have been related to the API that the Xiaomi OS uses, but I had this issue where when I would like videos on YouTube from my phone, it never actually saved the liked ones. And then when I go into my history, the last video I would have liked was the one like a month ago, even though I liked like 10 videos at that moment. So that's one bug we can say is related to an API. Loading or some server error. Yeah, perfect. Wonderful, Bino. Exactly. So uh, internal server error, you can see that. Also, resource not found. So you can try to reach a page and, for example, you mistype the URL. So instead of Facebook, you write face chapter. I don't know. And it just opens up an empty 404 page, which doesn't really exist. So that is a wonderful, wonderful example. Yeah. I see Samson wrote, my bank app won't accept my PIN fingerprint until I clear the cache on my phone, even after updating. Yeah, that's actually a valid API issue. Yeah. And this is actually it's a critical one, I would say. So that definitely is something that the team has to get on and fix ASAP because yeah, it could happen that you forget the PIN and then you're locked out. Wonderful. Yeah, and thank you all for engaging in this brief discussion. I'm going to move on now to the section, what is an API? So, as I mentioned before, the API is an intermediary that enables communication between two applications, between a user and an application, between two software systems. So essentially, it is an interface, and that is the abbreviation, Application Programming Interface. So the easiest way you can remember it is application programming interface, application interface. It is something that connects applications and enables their communication. Now, why is it important to have an API? Well, you might think, okay, but we have databases, and then we can just construct the front end and the back end and connect them to the database. Well, you could, in theory, do this. It is not the same as with having this intermediary that gets the information across so fast, so efficient, that users can't even notice how many operations are actually happening when it communicates with the backend and frontend. So if you didn't have this API, essentially, you would not be able to, let's say, get responses as swiftly as you could with just working directly with applications without it. So it could happen you just like a video on YouTube or TikTok, and then you wait for 20 minutes for that to be registered. And you don't really want to wait 20 minutes for that or to log into a page when you expect it to be instant. Also, it's very handy to integrate applications one into the other and allow them to communicate essentially, because imagine if you were making your own application for renting apartments, and then you wanted to add a map option so users can visually see where the apartments are, right? It would be very difficult to create the application and create a specific or generate rather a specific map only for your application when you already have something that exists and you can just reuse it. So it definitely makes life easier for both the users, for the developers and applications working efficiently in general. Now, the most common analogy for an API is the one we'll see here, which is the restaurant analogy. And what is the scenario? We're going to briefly go through it, and then we're going to do a rundown of the graphic as well. So you have this system, which in this case is the pizza store or the restaurant. And there you have everything. So you have the delivery person, you have the kitchen, you have the process of taking orders, delivering the food, the server. So everybody is part of that system. Everybody is working together. Then when you go there or you decide to order online, right, depending on your preferences, you have a pizza menu or a documentation. So you have every detail that you need to know as somebody who wants to get the service to essentially understand what you can get out of the system. So you have, for example, a margarita, you open and you see that it has, let's say, gluten-free dough, mozzarella, and ketchup. So essentially, that is the documentation. It tells you what and how you can get something out of the system. Then you have the order, which is an API call. So once you essentially know what you want, you say, okay, I would like to take the pepperoni pizza. So you send a call, you send a request with which you hope to receive what you ask for. Then the kitchen is the server where everything is stored, all the ingredients, the people who also need to prepare them, so who need to do, let's say, the functions so that you get the pizza as it should be. And then you have the delivery system, the API, just working around, sending the request, receiving it. So once the pizza is done from the kitchen, taking it as a server and putting it to you, which is in the end the response, or rather you get the plate of the pizza that you decided for. So this is essentially how you can imagine it. And it's a very good analogy. It's quite simplified. However, I would also recommend, this is a very nice graphic. So uh, you can use this as a reference at all times because I know APIs can be a bit confusing at the beginning. So how you can view it, you have the client side. So this is you. And then on the right-hand side, we have the API server, the API. So this is like the system, right? This is the system. And what do? You want to do something with a web page. Let's say we're on Facebook. So you want to send a request. So you want to log in. Let's say this is the login. And then the API says, okay, so Angelo right now wants to log in. Let's do that. So he takes that request. He goes to the server. Whatever needs to be processed here is none of our interest. So something is happening. Some methods are called, whatnot. Again, we don't need to know the details of the API. And then they say, okay, Angelo is in. You can send them the response and he can use Facebook now as a user. So essentially the API says, great, it sends some kind of code to 100. You don't necessarily have to see it. If you just dig down deeply enough, you will probably find a way to see it. But again, you just need to log into the page to say it's successful, and then you're on. And the best part about this, so this entire process of sending a request, it being processed, sent to the server, back to you, it's all done in a second. And that's why an API is very important and how it connects apps and users to the general system that they use. I want to ask, do you have any questions so far? Uh, I see. What is the difference between API and API server then? Um, Yeah, so I see Susan wrote the API is the waiter placing the order with the cook, the API server. So let me put it like this. So the API is what connects the, we'll also talk about this in detail, it basically contains all the methods to process the response and the request. So all methods that we probably have no idea what they do, right? Is the API. And then the server is just a place where the resources that you need are stored. So for example, it could have, let's say, specific endpoints, resources. Let's go with resources that you want to access. So when you log in, you probably need a token, and the server is actually the place where you need to get the token. The API just fetches and validates if the token is okay. So it's essentially a place where you have resources that you need to use for the application. That's as simple as you can get for the server. And then the API, of course, is something that essentially enables this communication between the two parties. Is that okay? Yep, no worries. All right. If there are no other questions so far, I will move to the next section, which is types of APIs. All right, so we have a few types of APIs and API architectures, which we will touch upon a bit later. We have the public, we have private, partner, and composite APIs. All of them are basically used everywhere, so it's not that some are more common than the other, but we will touch upon each individually as well. First of all, it's public APIs. Public APIs are essentially available to everybody. So it doesn't matter if you are working at a specific company or you're just somebody who likes to do some quote unquote vibe coding and explore capabilities of various applications that you create. You can use these public APIs. And you can build your applications of them. You don't need to necessarily, how should I say it, reference them when you use them. So it's basically open source and free to use for everybody. And I will relay back to Binu, who mentioned the Google Maps, which is an open to the public API, and you can actually embed it to applications that you work on. And you can also use it to test some scenarios. So I would not recommend trying to use it for load or stress testing, definitely. But you can try to get some requests from the Google Maps API. It's very neat. So it's definitely something that's accessible to everyone. So why not? Moving on, we have partner APIs. Now, I would like to make a relation between private and partner APIs. So both are in a way private. The difference is the partner APIs are only specific to business partners or a specific group of people within an organization. So picture this. Let's say you're working in a huge organization. Let's say, okay, let's use Amazon. And then, while you might have a private API that everybody can use, the partner one could be only available for, let's say, 10 people working on a specific project. And we have an example here for Spotify. It authorizes third-party applications like fitness or other music-related services. And one which I think that you all might have seen is Instagram. So you can actually add a story and then like add the music from Spotify to play on the story. And that is a partnered API. So that's not something that maybe every bit of Meta can use. So you can't use it on Facebook, for example, but you can use it on Instagram stories. So it's specifically catered for that bit, for that part of the team and for that organization. So it's only for those specific purposes that you can use it. Then on the other hand, the private API is for internal use within an entire organization. And APIs like this are most often those that are used for, let's say, payrolls or for doing access management for employees. So essentially, HR platforms use these. And again, they're not publicly available, but everybody within the organization can have access. And most often, what happens in larger companies, you usually have these internal projects that use these private APIs. And they're also a very neat way to practice when you get those internal projects running. Then we have composite APIs. Now, what are composite APIs? They combine multiple requests into a single interface, meaning you can do one call. So you just send one HTTP method to do something, and you actually get a response with multiple items, not just a singular one. So What is the idea behind it? You don't want to you want to access as many functionalities as possible with just one call. And this is most common in booking apps, and especially if you use some of the, I would say, budget airline applications like Wizz Air, Ryanair. Most of them usually use such an API. So what does it do? You essentially search for a destination, you book a flight, and then it gives you information for renting a car, for booking a hotel, discounts on, I don't know, maybe rental bikes, so services. So it shows you all of this information with you just inputting the information on what flight you want to book. So you get all of this, all of these options available to you just by sending that one call or requesting to get the info um, for the flight. Do we have any questions so far regarding the API types? Yeah, Eunice, yeah, exactly, like the Uber app. Yep, correct. That's exactly a perfect example for this. Okay, I don't see any questions, so we'll move to the types of architectures and we'll see after that. Now, when we talk about APIs, although we can differentiate between them in terms of it being public, private, or composite, so on and so forth, there are also things to note that they do require specific protocols to exchange specific data and commands. So there are some ways in which the API needs to behave so it can do the, let's say, data transfer between the applications. And that's why we have a few different architectures that are present here, which are REST, RPC, and SOAP. You might have heard of REST already. It's quite commonly used. We will see that I think it's about 70% worldwide. And we'll tackle a bit about each individually. So all of these three, as written here, are formats, and they have specific characteristics unique to them and specific use cases as well. For example, we have the remote procedure call. So this uses procedures or functions, let's say, to send to the endpoint and then receive some kind of response based on that. We will also see I have some examples for that in the notepad here. I'll show it briefly. Then we have the SOAP APIs, which is Simple Object Access Protocol. These are very strict and they only use XML. So they're mostly used for complex operations, for financial calculations, and mostly in banking or insurance applications. If you ever worked with such, I would say 90% of the time you would have to work with such an API. And then we have representational state transfer REST, which is a stateless and resource-based approach. It uses a standard URI or URL and fetches the items from endpoints. Basically, the one most common API that you might have already seen as an example. And as we can see here, the REST API is the most widely used. 70% of public APIs are REST. And this also applies to even most of the private and the composed and protected, because these are all based on wanting the best performance, wanting the ability to scale up. So you want it to handle as many users as possible, and REST is something that enables this as well. So I would, let me just draw this up. So I do have a few examples that we can look at here. So first we have the REST API. So what is the REST API? We said it just uses a standard URL URI to fetch resources from a server, whatever it could be, location. We don't know the specifics. It just uses the methods and the URL to give us what we need. So we have the request. We essentially write get, and then this is the HTTP method, which we'll discuss later. We write the URL with an endpoint that we want to access, and then we get this response in JSON. You can also get it as raw data, so we will talk about this in another lecture. And we see once we try to get the user number 42, we get the user with ID 42, and the name is Ada Lovelace. So this is essentially what you can expect from REST API. Quite straightforward, quite simplified, and very fast. So this is more tied to it. Now, moving forward, we have the SOAP API, and this, as we mentioned, is XML oriented. So you're not going to see any JSON style files here. And what is the trade-off? You usually have only one URL that you're always going to hit, so it's not going to change at any point. You're mostly going to use that. And what is the big, let's say, flaw of this type of API? So you have to write out the entire body at almost all times. And when you're constructing the body in XML, as you can see here, it looks a bit more complicated than it needs to be. It does take up a lot of time. The XML language itself is not so, let's say, intuitive as you can just finish up all these tags and items as you can in some programming languages. So it does take up a lot of time. It is not as fast as the REST API, but it's very good for more complex calculations. And then it gives you the response in the XML like this. From my personal experience, I would say I have worked with REST and SOAP up until this point. SOAP is definitely, it's not challenging, but it's really annoying to test, I would say, because unless you have a well-developed structure for the XML code that you need to send, you're not going to have a very fun time just writing them all over again each time that you want to do something. Whereas the REST API is a lot better, a lot more, I would say, improved and newer. So it's a lot more easier to use than the SOAP one. Moving on, we have the RPC API. So the RPC API, as we mentioned, uses functions or procedures. So how does it work? You have the standard URL that you're going to use. You write what kind of content you want to get, and then you're just essentially writing down the name of the method. So we see here method add, and then we use the parameters that that method needs to take. The important thing here is, especially in this API, you need to understand how those procedures work because you're always going to be using them. So you're not going to just send a value pair here, like let's say name Angelo, surname Pavlovsky. You're only going to be using procedures or methods. So we see we have this method that adds two numbers together. We add the numbers as well. And then in the response, we get a result. These are mostly used with distributed systems, actually. So this is, I believe, a type of API that Netflix and Disney use for some of their services for their content streaming. I will provide some resources additional if you want to read more about it, but it's not so widely used as the latter ones that we just talked about. Okay. Before we move on, does anybody have any questions? I see Anna's lost. I'm lost. I don't follow this explanation. How to relate it to anything. I'm sorry. Okay. I see Seraphim answered that. So I'm just going to briefly touch on the second question and get back to that. So Bin wrote, why is it post in SOAP and I saw get in REST? Could you explain both? Yeah, of course. So first off, these are just examples, so you don't need to really focus on that. So these get and post are HTTP methods. So you can actually use either one in both. So you can write here post as well. We can also put post here. Perfectly fine. You can add get here. You can use put. You can use delete. These are different HTTP methods, and we will talk about them later in the lecture. But this is just in the example that I wrote them like this. But you can absolutely use get, and you can use put. You can use delete and SOAP. You can do the same for the RPC. You can do the same for REST. So all of them are based on these HTTP methods, and we will touch upon them in the lecture moving forward. Okay. So Ines, I wanted to touch back on the question that you have. What is specifically the difficulty that you're facing with the concepts? Is it maybe with what are the different architectures? Do we need to do a bit more? Do you want me to go through them again one more time, if it helps? I'll wait a bit before we move on. And see if anybody else has any other questions. We can also go through them. I know this is a bit more of a complicated topic, so we can take a bit more time on the contents as well to make sure that we're on the same page. Uh, okay, I see. So yes, please, and examples you gave, I cannot actually relate to them. All right, I see. Okay. Then I'm gonna open this again. I'm gonna use these. I'm gonna use the example one more time, and I'm gonna try to go through each of them individually. We will have also a practical example later with the REST API. So I'm gonna save that for the lab exercise that we do later, if that's okay with you. And then we're gonna do a bit again this section. So what is the idea? Um, we have these architectures, let's call them. So these are different types of APIs. So they use different approaches to get a resource. So REST API is the most, let's say, the simplest one, and it's called stateless because when you send the request, so the server does not remember anything. It essentially you need to provide everything for it in the request that you're going to send, and then we will talk about some headers, authorization, so on and so forth. You don't need to get into the details now. We will define it a bit more later. But essentially, this one uses a URL. So this is the URL. It adds a specific endpoint, which is 42 in this case, and you just try to get the information on that resource, which is the 42. So when you write the request, you write it like so, get, and you copy paste the URL, and then you're going to receive a response for that endpoint. So we see this is the endpoint that we use, and you see what data you have there. Or actually, we just have the name. You could also have a surname could be added here depending on what you see. Then for the SOAP API, essentially, what you do is you again need to use some kind of method. So again, don't let this confuse you because I have get for REST and have post here. You can actually put get here as well. So I can just write it. This is just an example. You can add put, up to you. It depends what you're using it for, and you can only use XML. So here you can use JSON and XML. They're different data transfer languages. We're gonna talk about this as well. The idea behind it here is that it only works with XML. So when you use this, the code is a bit harder to read. It's slower than a REST API, so it's not as fast and reliable. And most of the time, when you need to generate, when you want to post something or put something, you're going to have to write these enormous amounts of text, which are quite complex and not really human readable in comparison to the one that we saw with the JSON, which is very easy to understand. And then the RPC, again, it does the same. It needs to fetch some kind of resource. However, this one works with functions or procedures. So in the first and the second, we saw that I was trying to just receive a resource with some values like a name, surname. In the second one as well, I'm trying to, so I changed it to get, but I tried to post some information about an account. In the third one, we specifically use a method. So we see I say method. This is some kind of code function like the ones that you use in previous lecture, let's say like splitting a string function. And I noted which one it is. So this function in the API is called add. Again, it's an example. And then I just told it which parameters to use, and I got the result. So you're using it more for procedures, for to test functions in an API, if it makes sense. And that is the difference between the three of them. So do you have any additional questions for this? Is it a bit more clear now? I'll wait a bit because I see several people are writing in the chat. Can I be exempted to test API? Well, I mean, there are projects that don't require testing APIs, but most of them do. better understood now? Thanks, no worries in us. Glad that it was of help. But it's very easy. I mean, at first, when you hear about it, it sounds complex. It really sounds complex. I know. Even when I was studying it, it took me a few months when I was younger to get this down. But it's very easy once you practice. I promise you. And it's a lot more interesting than you think. You'll also see we will have labs for this. It will be very simplified then. Uh, yeah, it's the thing I really struggle to understand how it's made, where it is, how it works, and so on. Uh, yeah, I mean, I will touch upon this in the conclusion as well. I have some summaries that might help with that, so we can save on time. So for the time being, I'm going to move to the what is API testing section, and we'll see what we'll do about that. What is API testing? Well, naturally, it's just testing how the API operates. So you're validating and verifying whether the functionality, performance, security, and reliability, all these aspects of the API are in order. And you can do so by using HTTP methods, which are get, post, put, delete, and patch. So you use them to test the API most often. And you just try to see how the responses are functioning. So are you getting responses on time? Are you getting direct response? Are you receiving the data that you need to receive? So essentially, you're just trying to make sure that the API communicates with the user appropriately. Again, you do not need to know the specific details of how some methods are defined in the API. You do have a documentation that you can rely on, but you definitely don't need to understand the code of how the add function works in the API. So you're just interested in the result that it provides. So that is basically the idea of it. Now, tying into this, we have this type of, as we mentioned before, shift left testing starting as soon as possible. So one way to test an API, aside from the standard one that we just said, you use some kind of HTTP methods and you're just validating the functioning API, is the API first development model. Now, there is a scenario where you could actually need to develop a new specific part of an application that will need an API that you cannot really reuse from the internet or from the client side. So you need to create it from scratch. And what is done in such a situation? It's something that is known as API first development. So what do you do? Essentially, the developers use tools like Swagger Hub, and they actually design the API. So they design what the API will have, which methods, how everything will be communicating, how it is integrated. So they design this, and then they can use that to generate their code to basically create the functional API. Now, where does testing come into play? As we discussed in some previous lectures, we want to start testing as soon as possible. So it is a case, very rare, but it could happen, that you have this situation where you need to develop an API. So you want to start in the design phase. So the developer will design the API that you need to use, and you can just go through it and you can see maybe some methods are not well defined or do not make any use of the data that you have. Maybe you will discover some connections don't make sense, or some scenarios where the network might be an issue performance wise. So you want to test both the design, and once you approve that everything is fine with the design, they generate the code and you test that, and in a way provide more trust and quality in the overall application just by checking the design and the functionality of the API. I will mention again, this is not so common on most projects, so you will definitely not need to test designs of an API on most projects. However, if it does happen so that you need to generate one from scratch, it is the correct approach just to make sure that everything is in place when you just test the functionality of it. Do we have any questions regarding this? I see nobody's writing anything. So I'm just going to move to the next bit, which is different types of API testing. Now, a brief question for all of you. You can write in the live chat. What types of testing do you think we can perform on an API? I'll give you a hint. I'm sure we have talked about them. We have talked about these types of testing. And they're more simple than you would think. I'll give about a minute. Again, no wrong answers. Just want to see uh, if you have maybe some idea of what we can test and what test actually we can perform. I see Nas wrote functional testing. Yeah, correct. Functional or system testing. Yeah, you can actually do both. So that's a very nice example. Yeah. Let's see if somebody else has something to add. I see more people are writing in the chat. I'll wait a few more seconds just to see white box testing. Yeah, you can actually do white box testing on APIs, and it is a practice. It is a practice. You can do it. As you mentioned previously, in combined type, if the integration between them works. Fantastic integration testing. That is correct, Valentina. Yeah, it's quite common to do integration testing as well in APIs. So as I can see, and as you can all see from the examples in the chat, it's essentially the same types of testing that we were talking about previously. So you can apply those types of testing to basically most components and types of software that you want to test, even APIs. So we have a few listed here, and I'm just going to use these ones. You mentioned white box testing. We're not really going to necessarily go into it, but it is correct, Bibi. So that's a very good example that you added as well. So essentially, let's say the most common ones that you will probably come across, functional testing. So you want to make sure that the API's methods work as expected. So essentially, you want to check whether if I provide correct credentials for my login, I will be logged in. So that's a functional aspect. So if I send correct credentials and then the API says, okay, you're good to go, then that means its functionality is in order. If I provide correct credentials and I don't get in, well, we have a bug on our hands. Then we have integration testing. So as Valentina mentioned previously, we have this communication between applications, or rather even between two APIs used in a single application. So you want to make sure that the interaction between multiple APIs or an API between applications is working as expected. And we have a very good example here. So you have an e-commerce API and you have a payment and inventory API. And you want to make sure that the order is processed from checkout to payment confirmation. So you want to make sure that everything starting from the item being selected to the item being paid for and that amount being, of course, validated and taken in works as expected. So this is how you integrate two APIs. You can also just test communication between one app and the other in the API. All of these fall into integration testing. Then we have load testing, which basically checks performance and scalability of the API. So this is essentially trying to see whether the API can handle a specific load of users at a given time. You can actually know this as performance testing, of course, and we will be learning about this in one of the next lectures. And yeah, essentially you can perform this with APIs, and most commonly it is done on APIs. So it's a good thing to remember. And then, of course, we have security testing. So you want to make sure that the API is not vulnerable, so it can mitigate any security threat. You want to check authentication, authorization, so you can check all of these within the API. And again, I will mention it is the best practice to test this within them. I'm not going to dive too much into detail about the security testing bit, so not to confuse you today, because we just want to understand the API concept. Then we have reliability testing, which is again tied a bit into performance testing. So you want to make sure it's reliable, it's stable, and it can scale up and it can work well in different conditions. It can recover if it crashes. So you want to make sure that all of these aspects of the API are covered, because in a way it is also one of the foundations of the application. Finally, we have mocking and virtualization. So you can actually mock APIs. You can also mock servers. This is a common practice when working on lower environments. And you have, at this time, at this moment in time, you have libraries that can actually do this, so you don't necessarily need to do too much work here. And usually, you can also rely on the development team for that. You mock an API so as similar as possible to the actual one that you use in production, so you don't actually break anything, and then you use that to run your test against it. Do we have any questions so far regarding the types of API testing? I see no questions so far. And again, these are, let's say, a handful of the tests you can perform. You can perform other tests as well. So you can also write even unit tests. You can also do white box, gray box, black box. All techniques can be applied to test APIs. So it doesn't because we don't have them written down here. It doesn't mean that they can't be used. You can actually do all types of testing on an API, and I also saw that Serafim mentioned that it's the easiest way for him to test a web application, and I really agree with this. I think uh, as time goes on, you'll really get the hang of it, and you'll see that you will also come to prefer this type of testing rather than just going on the web page and trying to click on the components to see if everything is okay. All right, I'll move on to the benefits and best practices of API testing. Now, as with any other testing, we obviously have some important benefits to keep in mind as to why we need to perform the testing. We have quality assurance, so we have to make sure the API works as expected. We have the trust of our clients, and that is protecting the business reputation. So we want to make sure it is stable, it is reliable, it has high performance, that it provides the functionalities that is expected of the customer, of the user. So just covering that, doing all those types of testing will make sure that we deliver such a product. Then we have finding issues earlier and resolving them. So as I mentioned, even if you start in a design phase of an API, you can find these issues in very early phases that can be mitigated or can be utterly erased when generating the code. So while doing this, you will see that the quality will just continue to increase and the workload will, of course, decrease due to us having catch these issues early on. Resource conservation. So you basically will save time, resources, and you will actually allow yourself and the team to focus on adding new features and adding new, let's say, things to the testing process rather than just manually testing everything. And then rapid iteration. When you have this integrated in a pipeline, you can have faster releases, meaning you can have reduced bugs and improved time to market. So as you basically add this type of testing in a pipeline, so it can be executed quite often. It will also catch any issues that may occur due to a deployment or due to a release. So it can just catch those issues in the pipeline. It can inform you, you can resolve them, and that is all in real time. So you don't have to actually just focus on, let's say, retesting everything when something is changed manually or doing the automation tests repetitively before it reaches this pipeline. So these are some of the benefits that we can see here. And some best practices, which I think are very important, are creating a dedicated testing environment. So you don't want to use the main API unless you have that opportunity to test everything. You always want to have a specific testing, development, whichever environment you agree on with the team, which is as close as you can get to production, where you can play around and destroy the API in every way you wish to make sure that it's working as expected. Automate API tests. You'll find that quite a lot, or even I would say the vast majority of API tests are automatable. And if you do so, you will you will basically save a lot of time and resources, and you can actually have consistent coverage, and you can reduce the human error, and also don't have to go on about rechecking all the things manually. Test route with the API lifecycle. So you can, of course, you can test, you need to test APIs at every development stage. So you want to address the issues as early as possible. Write reusable subtests and keep tests organized. These are given. So this applies to all types of testing. So you don't want to write new test cases every time you have a feature. You can also rely on something that was already created and just build up from that. And of course, having a neat organization helps in the entire process of the API testing. I see some questions. So Valentina wrote, will we use same tools already mentioned for APIs too? Um, will we use same tools already mentioned? Yeah, we will use some tools. Actually, we have them on the next page. We will both use tools for automation and we will use for manual API testing. We will see the difference. And both are very useful actually, and we will talk a bit more on that in the next lectures. But we will definitely use tools to test. Okay. Yep, yep. We will use Selenium and we will use TestNG. I think the first one is TestNG and then we will use Selenium. We'll also use Postman, but I'll touch a bit about that in the next page. Okay, before we head for the break, I have one more thing here, which is the popular API testing tools and frameworks. So you might have heard about some of them. They're all listed here. We have Postman, SOAP UI, Catalan Studio, Apache JMeter, Rest Assured. So these are just a handful of the possible tools and frameworks you can use for APIs. Of course, they vary for automation based on programming languages like Rest Assured. For example, this one is a library in Java, which you can use for writing automated API tests. This is something that you will also cover in the lessons. And you can have RESTful in C#.NET. So every language has a specific way you can test it. You have tools like Playwright, which I've sent before, that you can use for automating API test scenarios. And then you have JMeter, used for load testing more often. You can use it to test whether your API is all right with its performance parameters. Then we have SOAP UI, Catalan, and Postman, mostly similar, provide different aspects of more, I would say, manual API testing. And we will definitely use Postman for the exercises in the next lecture, which I think you will find very interesting. It's quite engaging, and I think it will really much help. It will really support your learning of the materials regarding APIs. So this is just a handful, as I said, again, of the API testing tools and frameworks that you can come across. And most of these are used on projects. So Postman is, I would say, by far one of the best API testing tools that you can have. It's very convenient. You can use it not only for testing, you can also use it to check some things that you might need to add in your framework. You can also validate, as I mentioned, manually. You can make some modifications, but I'll touch more in detail on that in the next lecture. So, do any of you have any questions regarding the tools that we just discussed about? I see Valentina wrote, are they free? Yeah, you can download Postman and JMeter and REST, all of them for free. Yeah, absolutely. You can at any time. You can use them. You just have to find some APIs that you can also use, public APIs, uh, and make sure that what you are doing with them is also correct. And that also usually that is written in the documentation if there are some limits. So if you can't, for example, let's say use 2000 users, it will be written. It is explicitly stated. Yeah. No, it's you can absolutely use them. I mean, you can especially for just standard HTTP methods is perfectly fine. So you can absolutely make use of them. I see Bruno wrote, have you worked with all of these frameworks or which are they? That's a very good question. Thank you, Bruno. I have worked, most of the time I've worked with Postman as well as REST Sharp because I mainly code in .NET. REST Sharp is the C#.NET version of REST Assured. It is the same. It is used for automating API scenarios. And I've used by far the most Postman and REST Sharp, and then Apache JMeter for load testing. So this one is quite common, and especially I really recommend it for beginners to do performance testing. It's very intuitive, it's very simple. It's really good to get your idea across of how you want to test non-functional aspects of the system. And then Postman is just the best for beginner friendly, and also it has very advanced features that you can build on. So yeah, from my personal experience, Postman, JMeter, and REST Sharp or REST Assured, the Java one. So, and these are, I think, the ones that you will most often use as well. So, okay. If we do not have any additional questions, I think we can have the break right now. So, yeah, you can take it away.
Very soon.
All right, I'll share my screen now. It's I really feel happy to have won my first ever duck race. This is I'll cherish this moment for forever. All right, so let's get back to API introduction to API testing. So last bit we left off is what is JSON? So we've already talked about a bit about this throughout the lecture. Maybe some of you know what it is. Maybe some of you will find out today what it actually is. And it's quite straightforward. It is a JavaScript object notation. This is the abbreviation. It is just a lightweight data interchange format that is basically used for applications to transmit data in between them and showcase it to developers, testers alike. So in a nutshell, if you want to, let's say, um, remember it more easily, let's say, um, you can say that it is, in a way, the zip file of applications. So not in a way that you compress it or that you need to open all the files within it, but rather you have this data and you want to send it as fast as possible, and you want to have its size as small as possible. So this is what JSON is. So when you want one part of the application to communicate with another, you will use these JSON files to send the data to one another. Now, um, what is good about JSON? So one of the good things about a JSON file is that it is very straightforward. It's human readable. So once you see it, it becomes evident what you actually have and what you're working with. So we can see here we have this snippet. So we have some values on the left side and some on the right side. They are different. So essentially on the left side, the name, the age, and the city are known as keys. And the ones on the left, so we have John Doe for name, we have 30 for age, and New York for city, are known as values. And we call them, these pairs, key value pairs. So this is the basis of a JSON file. You have the key and you have a value for every bit of data that you want to transmit, that you want to exchange, that you want to use in the project. And when you see it, it's very intuitive. So you know that name is some kind of string, which is John Doe. You have age, you know that the value for it is 30. So it's quite easy to understand and it's human readable. And that's one of the best parts about it. And you might notice that the values, after the end of each value, there is a comma separator. So these are done to distinguish each one. So we have one before the one after the first one, the second one. And when you reach the last item, you don't add a comma, you just leave it as it is like this. And very important, they have to be enclosed in curly braces. So uh, essentially, this is the simplest version you can see of a JSON file. Now, why use JSON and why it is so handy and important? First off, as I mentioned, it's simple and easy to read. So it has a straightforward syntax with the key value pairs that we saw with nested structures, and it is very easy for people to read. So developers, testers can use this to validate data, to modify some methods that they need to modify once you see and understand what you are working with. Then it is lightweight. So in terms of data size, its memory is negligible. So it's very small, it's very light. As I mentioned, think of it as a zip. So when you have files that are maybe 50 gigabytes large, when you compress them, they immediately drop in size. This is essentially the compressed size. This is so lightweight that it does not have any additional info that it does need to, and it's very fast when it comes to transmitting data over networks and from one application to another. So it's very fast, very lightweight, very efficient. Third one, and the one I want to highlight the most maybe, is that is language independent. So it can be used in many programming languages. What do I mean by this? So even though it is JavaScript object notation, it just carries this name due to it initially being designed for JavaScript. So it was primarily meant for that specific language, so it could be used for web applications. However, nowadays it is made to be used across any language. You can use it in Java, you can use it in .NET, you can use it in Python, any object-oriented language you think of, you can actually use JSON files. So that is one of the best parts about it. And it is well suited for representing hierarchical data structures. So this might sound a bit complex, like such as objects and arrays. So what is meant by hierarchical data structures is that when you open a JSON file and you see a list of items of data added, it actually represents the nested structure and how the data is represented. So in a way, um, when you, let's say you have a directory and you have a lot of files in it, and each file contains a subfile, when you open them and view them in a tree, it's quite easier because you have an overview of each file. You see the directory, you have all the files under the specific file, and that is how JSON shows them. So you might have the name here, and if the name contains multiple items within it, they will be nested below the name, again, with their names and values assigned. So that is the, let's say, hierarchical data structure it refers to. So if you have arrays, if you have objects, they're very well and neatly displayed in the JSON file, so you don't need to worry too much about how to extract and get the data across. Nowadays, it's actually, I would also add, the most used file format, again, due to its efficiency and as well as the ability to work with all data types essentially that you would need both for testing and development. Do we have any questions regarding this bit for JSON? I don't see any questions coming in, so I will move on to the data types in JSON. So, um, JSON supports different data types. The thing about it that I want to mention is I think you've already saw some of these in the fundamentals of programming, and basically they are the same here. So you have strings, you have numbers, you have booleans, you have arrays, you have objects, and null. The strings use quotes, double quotations to showcase that there's a string value for a key. So that's how you know that you're working with a string. When you use numbers, you use numeric data, so you don't need double quotes, and you can use integers or floating point numbers. So you can say age 30, or you can use area 50.5. So you can work with both floating and integers. It's important that you don't enclose them in double quotations. You have booleans. The standard values for booleans here are true and false. You also have arrays, which are collection of values which are closed in square brackets. So that's how you differentiate them. You can already see we have the more or less similar way of representing them in the way we do in programming languages like in Java. So the array has these square brackets, booleans true false, numbers are integer numbers or floating numbers, and then we have quotes for the strings. And then we have objects, which are unordered collections of key value pairs that are enclosed in curly braces. We'll see a brief example. This is essentially an object is something that contains, let's say, uh, multiple key value pairs, then make it up, similar to when you were working with classes. So classes that created objects, so they usually have more values, uh, and those are represented as such. Here we can see actually two examples, small examples of how an array looks. So when you write the array, it does have the square brackets and you have all the items or the values rather within that array. And the object, as we can see here, the key fruits has apples, banana, and orange. So basically contains this array that we saw here as the value. So this is essentially how you would represent it in a JSON. Now, the big thing about JSON, it supports nesting. So you can actually have items within items. You don't have to just list them in a singular place and then wonder which one was the array, which one was the object, which one is the string, and so forth. So you can actually nest them one into the other. And we can actually see this example here where we have this very simplified, let's say JSON. So we can see we have key name. It has a string, which is John Doe that we saw before. And then we have address. Now, this points to an object because we see the curly brackets that are open here. And that one contains the city as a key with the value New York, and it also contains a zip code with the value 1001. So we see these two keys with these values make up this entire object, or rather the address. So it has those key value pairs. In addition to that, we have the phones, which contains an array of objects actually, because we see the square brackets here. And then those objects in themselves have the key value type and home and number, both of them having the same but different values, of course. So you see within a JSON, you actually just get the information and the data you want to use, or it is essentially just transferred between systems and applications. So it could be as efficient as possible. And even when you come across it, it's very easy to understand what is happening, what is used. And you can actually even use, when you look at this data, to go into the code if you're a developer to debug, or you can actually just see if some tests are failing, at which point they're failing. Is that maybe some of the data that we try to access is not an array, maybe it's just an object. So you can just actually have a lot of possibilities uh, when testing data and reading it from JSON file formats. Again, it might look a bit complex at first when you look at it, but I promise you, with enough testing and practice, this is very simple, and you will come to terms with using these files a lot, and there'll actually be a preference for you even when working on automation frameworks and keeping data sets that you need for testing within them. Do we have any questions regarding this? Okay. I see a very nice gift from Seraphim, Jason, my beloved. I can agree. All right. If there are no questions for this section, we can move to the REST API. I would say one of the, let's say, most important bits that we want to cover in today's lecture. Now, we briefly talked about the REST API at the beginning. We said it is an API architecture. And what do we want to remember here? So here, the server does not remember things that you send within a request. It doesn't need to. It just needs to validate whether you can send a request so you can get an appropriate response, or if you cannot. Now, this might sound, again, a bit more complicated, and I think you'll see just how straightforward it could actually be. Because what is the idea behind it? The idea of a REST API and how it works is that it has, I would say, three parties. So you have a client, which is, let's say, the user. You have the API that works here, that does all, let's say, the dirty work. And then you have the server with its resources. So what happens is you have this client, which is usually an end user. And most of the time when you're going to be doing the testing, you're also going to take the role of the client. And you want to request some kind of information to perform some actions on a website, right? That website has some kind of server, which is here at the end. So what you need to do is you need to send a request. The API forwards this request, so does the necessary processing that needs to be done. Again, as we discussed, we don't need to know what exactly happens within this REST API, and we can't really know. It sends it to the server, and let's say you are requesting some specific resource. So this all goes into the server here. Now, on the server side, you can also read about it here, is basically part of the application that gets all the requests from the clients. It has the resources that you need, that you want to access, and it uses the API to essentially bridge the communication between it and the client. So this is essentially the bridge that we use to process and get the request from the client to the server, and the response vice versa. So the server contains all the resources that we need. And the resource in itself, which we'll also discuss a bit more in detail here, is some kind of information that we as a client need. So we need this piece of information in order to perform some kind of action. So it is stored here on the server, and we need that resource when we send the request. It is usually added into the URL. It is the endpoint, which we talked about a bit, but we have a section for that, and we'll cover it there. And essentially what happens. So I say I want to perform some action on the page. So I send the request. The API says, okay, I see what you need to do. So I'm going to see and process this to the server. And the server says, we have the resource that you need to perform that. You are authorized to do so. So he sends a response with the code, usually 200. Okay, you're good to go. The API processes that, sends it back to us, says, you're good to go. So you wanted to log in, you provided the correct credentials here, we validated that they were okay, and the API says, okay, you can log into the page, and we're in. So that is basically the entire flow of the REST API and the connection between the client and the server. And essentially, this happens in, I would even say, milliseconds or a second of time. So all of this communication that we just talked about is super fast, super efficient. It could be a bit slower on larger systems that require a bit more, let's say, jobs and tasks that need to be performed, of course, but more or less the general picture is that this happens very fast. So do any of you have any questions so far regarding the, let's say, the structure of the REST API? Okay. If not, I'm going to move to the HTTP request section. So um, now let me just, okay, there we go. I thought my screen was stuck. So what is the request? So we talked about the requests being sent to the server via the API, and we're trying to do something, but we really never talked about what the request actually is. Well, what is the request? The request is essentially something that the client needs to make in order for it to get the resources that it needs. So it's same as always trying to ask to get something that you need to finish some operation. So if you want to, let's say, play tennis, you would need to go to the club, request the racket, and then you use it to play. So you provide the request to get the resource for which you need to do an operation. And the request, which we're talking about, is made up of a multitude of things. You have the method, the HTTP method, you have an endpoint, you have the headers, and you have the request body. Now, in this picture here, we can see an example request. So what are the elements of it? First of all, we have the HTTP method. We saw it in the Notepad examples as well. We have the method, which is post. So the methods can be different. They can be post, put, get, delete. We'll talk about them as well. So you need to add that in order to perform any kind of request. If you don't add a method, then you technically can't make any request. Then you add the endpoint. So here we have some URL added next to the method. You have to have a URL because you want to get some kind of resource from an endpoint. And if you do not have the URL, well, you won't be able to access that endpoint. Following that, we have these two bits of information, which is content type, JSON, and then authorization, bearer ABC. These are part of the header. And what the header does, it adds additional layers of both security and justifying what kind of content needs to be used so that the API can respond appropriately. And the authorization, which we'll mention a bit again later, is very important because most APIs do require some kind of tokens for you to get the resource. So you can't just try and get the resource without providing this authorization, especially when working with private and protected APIs. Finally, we have the body. In the request body here, we see we have two key value pairs. We have a name with the value John Doe and the email for that individual. Now, what I want to highlight here is although this request does have a body and a header, certain scenarios you can actually leave out the header and even the body. Now, when you're working with post or with put, you usually do have to have a body, and we will see why. But when you use a method like get, when you're just trying to get a resource, so you don't want to update something, you don't want to create anything, you just want to, let's say, get information about a football match. You want to see what's the result. You don't really need to send the body in the request. So you can just add get, you write the URL, and you're all set. So you just want to see what is the score. You don't really need any information on the body. So there are scenarios where you can omit the body and the header, and we will touch on this later on. However, this is the most, let's say, complex and standard type of request that you can see here, and this is of type meta type post. Now, do you have any questions regarding the request itself? Okay. I don't see any questions being written now, so I guess we can move on. Then I will go to the next bit, which is the endpoint. Okay, so what is an endpoint? The endpoint is a specific URL that represents a resource. So um, essentially, when you send a request, you usually send it for some kind of resource, and that resource is the endpoint. So that specific place on the server or wherever it might be on the application is the endpoint that you are trying to get the resource from. So it is a part of the URL, and it basically follows the specific pattern, which we can see here. So you have the base URL. So this is some API that exists. And then we have the endpoint, or rather the location of the resource, which is users. Now, mind you, when we're talking about an endpoint or a resource, it doesn't necessarily have to be one singular resource or just one endpoint. It can actually be, it could be a collection of items. The thing is, that resource or endpoint just has that abbreviation. So when we're talking about endpoints, it can be one item. You can only get one piece of data. You can get a batch of data, so you can get multiple items. It depends on what that endpoint holds. So we have the endpoint for the users, which is users dash users. And when you want to access that specific endpoint, you will need to have the complete URL, which is the one that we had in the base. So example.com dash the endpoint, which is users. So you can play around with different types of endpoints depending on what you really need to test at the moment. So this will vary for different requests, obviously, and we will see that in the exercise today. And again, these endpoints are related to the HTTP methods, which we mentioned, get, post, put, and delete, and they define the actions that the users or the clients actually can perform on the resource. So you can get it, you can update it, you can create it, you can delete it. So all comes into play with that resource. And of course, there could be some limitations. However, again, that depends on project to project. Um, any questions regarding the endpoints? I see somebody's typing in the chat, so let's see if we have any questions. Uh, okay, Inez wrote, we can't get any real life examples such as this one, can we? Like say Facebook, see post. Um, well, technically, I don't think we can use Facebook for this. We will have a lab exercise where we will use an actual public API, where we will try to get the endpoints. But in a way, that what you just wrote, like Facebook.com, Ines, um, you can actually, in a way, let's say, uh, you do have that endpoint when you click it and it opens up your specific profile. So in a way, let's say that is an endpoint and you can actually reach it using the web. But most commonly, uh, when you're working with these resources, you're not really trying to, how to say, get them and see them in a web application, you're actually going to be looking at JSON data. So when you, for example, let's say you write down the HTTPS facebook.com in us, right? You're not going to actually open the page to see it. You're just going to write get, let's say, and you're going to get a JSON with the data about that Facebook user. So you might get the ID of your profile, you might get your name, you get your surname, maybe you added a profile picture so it shows the path of that profile picture as well. So essentially that's how you get it. But we will see in the lab exercise later actually how this data is represented with a public API, one that we can use pretty much for many scenarios. Okay. Yep, no worries. Okay, then I'm gonna move to the next section, which is the HTTP methods. Now, this is, I would say, one of the most important bits of the HTTP request. And why so? If we don't have an HTTP method, well, then we can't really request anything, and we won't get a response, of course. So these methods are standardized actions that define which operation will be performed on a resource. So we have multiple types of HTTP methods. And what we do with them is we specify what kind of request we're making to the server. So just think of it of whether you want to, let's say, get information about a profile on Facebook, like Ines mentioned, you would use get. If you want to, let's say, uh, upload a new profile picture, so you want to change your existing profile picture, you would do put. If you want to create a profile, so you want a new profile, you've never had this profile, nobody has it, you would want to do a post. If you want to remove your profile and you want to delete it, you don't want to be on Facebook anymore, you can just delete it, and that would be that type of request. So let's get a bit more into detail with all of them. The first one, and the most commonly used one, and I would say the most frequently used one in testing, is get. So what is its purpose? Its purpose is to retrieve data from the server. So again, quite intuitive. You want to get data, you want to get the resources to you and see what you have at hand. So again, it works for collections, it works for a single resource, and you don't modify anything. So essentially, you just fetch data from the server. So here we have get API users. When you do this, you would usually get a list of users with names, again, depending on what the API stores, with their name, surname, maybe email, ID, so on and so forth, when you write the get action. And that is all. So you're not modifying, you're not meddling with the data, you're just receiving information. I see a question. Does users refer to a specific user profile, or it can be anything such as a function in a web page? Well, the users that you see here is basically it refers to the resource. So it doesn't necessarily have to refer to user profile. It could be a list of users. It could be maybe just the names listed. It could be we don't really know at this point, like, because we don't have insight on this API. And that's why, as I mentioned, you have a documentation. It tells you what you get from it, so it could vary. But in this case, it could most likely be a list of user profiles, most likely. So you have their names, their IDs, their emails. It can also be just names and surnames. It can maybe be just mobile numbers for all we know. We don't really know the details. This is just an example. But it is a resource, so depending on its definition, it is what we have in the documentation. Moving on, we have post. So there, uh, this HTTP method creates a resource. So we will see one additional one, which is very similar to this one. Post creates a new resource on the server. So most practical example, I will use it again. Thanks to Ines for mentioning Facebook. I think it's quite straightforward. Um, when you create a profile on a social media platform like Facebook, this is how you do the post. So this is the correlation to the post method. So when you create a new non-existing fresh account, it is created on the server. So it is created with the post method. So a unique identifier is generated, your name, your surname, everything is added there. So you could technically have the same name and surname with somebody else, of course, but you have a unique identifier which is added to you. So we see the server generates the ID for the new resource. So it has to differentiate so you don't have duplicate accounts, right? So you post something and the resource is created. It's a new unique resource by itself. The way it works is we see here we have the method which is post. Again, here we have the endpoint where we want to create it, and then we say with the header what kind of content it is, and we use the body. So when you do a post operation, you always have to have a body. If you don't have a body, you're not going to essentially create anything. You're just going to have an empty shell existing somewhere out there. So you need to have some kind of body and data within it, so key value pairs on what that resource contains. So if you were to create your profile on Facebook, most often not, you usually add your name, you have an email, you have a surname, and maybe you can also choose a profile picture at the beginning. So it might also be added here as a string with the path of where it is saved. So you could maybe have those added in the post request for that. And again, when you use post, you create a resource. So you don't update, you don't modify, you just create a new from scratch resource, and it is assigned a unique ID. So basically, that is the idea of it. Now, the other method, which is quite often confused with post, is put. Now, put, unlike post, doesn't create a resource, it just updates something that already exists. So um, when we said that we created our Facebook profile, we had to use post. Now, when I already have my account, let's say for a longer period of time, let's say I want to update my profile picture. So this is where put comes into play. So what it does is you just here, as we can see, add put and add the resource you want to update. You can also add users as well. So you can update the entire list if you wish to. You can change some names, so forth. But usually we see here that we have the specific user that we have created, 1, 2, 3, and then we update the name and update the email. In the Facebook case, let's say we updated the profile picture. So what would happen in the background is a put method will be sent to our, let's say, name here, Angelo Pavlovsky. Let's say that is the endpoint. And then here in the JSON file, what will be shown will be that the profile image path is updated. So maybe the profile image previously was the image noted as angelo.png, and now it is the same path, but now the image is known as angelo2png. Let's say angelo new.png. So that is the update that it makes. Now, where is the confusion that happens between post and put? When you use post, uh, basically when you use post, you always create a resource. So at all times when you use post, you only create, and that is all you do with post. However, when you use put, if the resource that you're trying to reach does not exist, so let's say 123 was something that never was created, put will first create it, and then it will add the necessary data. So put can also create, but in a scenario where the resource that you want to, let's say, add data for doesn't exist. So post can only create, while put can update, and when a resource does not exist, it can create it. So that is something that is very important to keep in mind, and I highly recommend to remember and focus on this, because this is something that really gets asked a lot for testers on interviews. So they will 90% of the time ask you what is the difference between put and post. So post creates only, and put updates a resource, with the exception that it can also create it if it doesn't exist. So I'd like to let you know to keep that in mind moving on. The final method that we will be covering is delete, which removes a resource from the server. It's quite straightforward. Um, I see just a question now, Mori. It says, is post run automatically? What is creating? Um, Basically, all of them are run automatically when we're using pages. So when you use Facebook, you don't technically do any post or put yourself. This is all done in the background. But when you write tests, for example, when you will be testing applications, if you use Postman or if you write automated scripts, you need to write down the post or the put method yourself. So you want to specify whether you want to test post or you want to test put, depending on what you test. If you want to test a file update, you can run a put method. If you want to create a resource, you will write a post. So when testing, you need to specify them yourself. So you need to write down what happens by yourself. And if it's something when you're using a web page, you're just using Facebook, Instagram, whichever page you like, these are done in the background automatically. So these are all set up. You don't know how they're set up really, but they run automatically. Hopefully that answers the question. And now, as I mentioned, delete, it removes a resource from the server. So you want, let's say, you want to remove, let's use the previous example, your profile from Facebook, so you don't want it to exist for whatever reason, you don't feel secure, you can always delete the profile. And when you do that, this happens, as Omori mentioned, automatically in the background. So your account is erased, is deleted. It no longer exists on the web. It's no longer in the server. So this is the command that is done. And how it is run, you just write delete, same as the ones before, and then you specify which resource you want to erase. In this case, the account that was on 456, let's say this is my account. This is what is run. It's quite straightforward. And when you use delete, you don't need any body, you don't need any specifics. You just want to erase the resource. Yeah, and basically, the REST API is built on this foundation of these methods to manipulate and play around with APIs. So whether that is receiving data, creating, updating, or removing it, these are generally the foundation of all those processes. So it's very important to distinguish how to use them and then use them in practice to get a hang of how all this information is worked with. Do we have any questions regarding the HTTP methods? And for that's a good question actually, Minu. And for delete, if no resource exists to delete, what will happen? Essentially nothing. So you won't delete anything. So if nothing exists, you most likely will get a response that the selected resource does not exist. You will get a response code stating that. So yeah, you will not essentially you will not delete anything. You just get that you can't delete anything. Imagine it, if you don't have a Facebook profile, you can't ever delete it, right? You can't access something that there is not there. So you just get the information that it doesn't exist. Hopefully that answers the question. All right. If there are no additional questions, as I see, yeah, wonderful. I will move to the request headers and body. Now, we saw these two parts of the HTTP request previously, and let's touch a bit what they are in detail. So the headers provide additional information for the request. Essentially, they're used as, I would say, this are used as well for a bit more security and for having better overview of what you have in the request. Now, they can have the format of the data that you send, they can have authorization details, and you can have caching preferences. So you can use no cache if you don't want something to be cached. And what do they usually have? As mentioned, the content type. So you specify the media of the request body. So if you're sending a JSON, you can specify it's a JSON. If it's an XML, you can specify it's an XML. So you're just saying what kind of content you're sending with the body. Authorization, it can contain credentials for authentication. As I mentioned, when you're using private or protected APIs, or partner rather APIs, you usually have to use some kind of token, an authorization token, in order to get the resources. So most often than not, you're going to have this authorization in the header. So you're going to have a variable, let's say, it's called authorization token, and you need to paste this token as its value so that when you send the request, the API says, okay, I see you have a token to fetch the resource, you're good to go. And then we have user agents. that identifies the client making the request, and other, you can also add other items to the header. You can also do a bit more reading on what those are. There are plenty. You don't need to remember them by heart, so it's impossible to remember all the details that you can add in a header. However, it is very good. It's a good practice to actually use them, especially for authorization and some other specific details for the requests. Now, the body contains the data that you sent from your site to the server. And um, why do you use the body? Well, you usually use the body to create or update an item. So when you use a get method, you usually don't really need a body because you just want to get a resource, information about the resource. However, when you want to create or update something, you most certainly will need a body for it, because you need to specify which part of the resource you want to update, or what data do you want to have for the resource that you create. So um, again, if I'm creating a profile, I need a name, I need a surname, and I need an email. So I have to add those in the body. I have to I have to use a post method and use these within the body in a JSON format and send them to the API, through the API to the server, so that it can create the resource with those. If I want to update my email, I will definitely need to add a body where I will specify which email I want to update. So what is the new email? And use that method through the API to the server to update my existing data. So the body just provides extra information or general information that needs to be added for a resource when creating it or updating it. Um, do we have any questions regarding the body and the headers? See, some people are writing in the chat, so I'll give a bit more time here. Which case is body optional? And could you give me an example? Yeah, but why not? So, yeah, let's say I can actually just reuse some of the examples that we had here, basically. So, as you see for the first request here, we're trying to get a user. So we're just trying to get information about the user. We just want to get their name. We want to get maybe their surname as well. So we're just interested in fetching some data about this user. And when we want to fetch the data, we don't really need to write a body to say what's their name, what's their surname, because we won't be needing the data if we know the data. So you just write the URL, you write the get method, and then when you go, once you execute this method, you will see the response, the ID of the user. So this is number 42, the endpoint, and then we have their name. So essentially, um, stalker method, yeah, a bit, but no. When you want to get that for a specific user, especially in testing, you just want to specify the endpoint. So you write down the endpoint here, or you can also just get the list of everybody. So you can get the list of all users to make sure that they're all stored. Maybe there are some missing users in the list of users. So that's also a valid scenario. So when you want to get information, you just want to get information, you don't need to use the body. You absolutely have no need for the body, and you just get all the data in the response, which also has its own body. So the response will most likely always have some kind of body that you will get. But in the request, so this area here, you absolutely have no need to define anything in the body. You just want to get information. Hopefully that makes sense. Yep, no worries. Yeah, essentially that is what a request contains. So as we mentioned, we have the header, the body, the endpoint that we want to specify, and then the HTTP method associated with it. So whether we want to create, whether we want to update, or we want to just get any information. In addition to that, we have the HTTP response, which I think we can tackle after the break. And then we will have a very, let's say, interactive exercise with testing some API calls with Hopscotch. So yeah, but I think we can go for the break now, and we can continue with the remainder of the lecture later. Okay, everyone, welcome back. Hope you had a bit of time to refresh for the break, and let's go for the final bits of today's lecture, which will be the response and then a brief exercise. So we talked a bit about the request part for the REST API, and now, as we saw from the initial graphic, we have the client that sends the request. We said that in this we have a specific body, method, endpoint, so what we are trying to get from the server, or rather which resource we're trying to reach. And then in order to see that data, we need a response. So we need some kind of action to be performed, or in other words, send us some kind of let's say result that we're expecting with our request. So if we are sending a request to login with valid credentials, we expect to be logged in. So that is the response. Us being allowed to log into a page is a response from the request that we did. If we're trying to find items on an e-commerce page that are, let's say specific shoes like Jordans, we send a request, we search for Jordan Air 1, and the response is the listed items that are Jordans. So let's say 3 items from that category. Now, the response, similar to the request that we talked about earlier, also has some kind of structure. So it is not only the request that needs to have a, let's say, body, header, status, and method, and so on and so forth. It's actually the same for the response. There is a slight difference, so it's not the same as the request the request that we talked about earlier. So let's take a look at the structure. So in comparison to before, we had the HTTP method. For the response, we don't have that. We actually have a status code. So the status code is something that tells us how our operation was processed and executed. So depending on what happened, whether a resource does not exist or if everything went smoothly and successfully, we will get an appropriate status code indicating what happened with our request. A header is displayed based on the one that we send. So what is the content type, length, authorization. So it depends on what you get from the response and the API. And then you have the body, which is similar to the request body. The difference being here that you usually receive whatever data the resource has. So it could be a scenario where some resource has all the data points, some has only a few, and you will get only those that are present for the resource. So let's take view here at the response. So at first we have the status code. So 200, you might have seen it at some places, is okay. So everything is working as expected. When you see this, it actually means that everything is okay. We have the header containing the information like content type, the content led server, and date. So we have the application JSON. This is usually what you will receive when you send the same type. You have what is its length, you have what is the server name, and then the date when this was performed. Again, these don't always have to be sent. It's good to have all this information in the header so that we can, let's say, add timestamps and information on which server, which environment an issue occurred, for example. Following that, we have the body. It is similar. It is in a JSON format, the same format we saw in the request. And essentially, it contains the data related to the method to the resource that we try to reach. So we see we have a status update. It says success. And then we have the data, which includes the user's name, and we have their mail. So when you usually send a GET request, so let's say the request that we were initially talking about with user/42, then you will receive the data in this format. So you will see status success, or depending on the status code, it could actually be not existing, so on and so forth. And then you would get the data related to that resource, which is currently the user and the email. If they had a profile image or maybe a phone number, they would also be listed here from that get method. However, this is all we have for this specific resource. And the way we use this for testing, when validating, we want to make sure that the status code that we're testing is the appropriate one. So it doesn't necessarily mean it always has to be 200, so it has to be okay. Sometimes we might do a negative scenario So we want to see if that data does not exist. So we would expect something like 404, 400, so depending on the test, right? And the second validation we usually do is the data. So is the data that was added as dummy data the correct one that we see? Because it could be a case that we get, okay, everything is fine, the request went through, but we're not getting the correct data. So this is what you essentially want to be looking for when doing these specific tests in the responses. Do we have any questions regarding the response so far? If not, we're going to go for the status codes. Now, similar to when we're talking about the HTTP methods, the response status codes are, let's say, in a way, the same tool in the response, what the HTTP methods are in the request. So these response status codes are essentially something that indicates whether the application in general is working as expected. So they give us information on whether something maybe something has crashed, or whether something is working as expected, something does not exist, if something is unauthorized, if something is forbidden for us to access as users. So this is generally the information that the status codes provide. And you might have seen some status codes when trying to access applications. So if you want to share, does somebody want to write down a status code that you might have seen on a page, on any page that you have used throughout your lifetime? So do you want to share any status code? I think you've all seen at least one. Being road 404, yeah, perfect. Not found. That is the the one that you see maybe the most often, especially when you also write some typos in the URL. 200 and 300, yep. 301, okay, interesting, nice. Yes, 200, yep. So in one way or another, you have all seen or have come across these status codes, and we're just going to see what they actually mean. So you will notice we have an enumeration from 1 to 5. So they go from status codes 1.x.x to 5.x to x, and we're just going to see what is the difference between all of them. So the first type of status codes is 1xx, otherwise known as informational. So basically, these codes uh, just give let's say general information. So they said that the request was received, understood, process still ongoing, the client should wait for further instructions. They are not commonly that visible for people on the World Wide Web, so you're not gonna run into them that often. You might actually see them in the very bottom right of an application, which takes a bit long to process a request, and it might send you some information data like 101 that let's say something is still being processed in a way, so you might come across them, but usually you're not gonna come across these that often on the internet. But still, you might have seen them in the very bottom right corner where something is still processing, and you get an info that your payment is maybe still processed, so you could actually note that. Then we have 2xx, which is success. So everything that has a 2 is a successful status code and indicates that some operation has been done as expected. So the request was successfully received, understood, and accepted. The one that some of you wrote, 200, okay, everything was successful, everything works. You see the page. That in itself, in a way, is a 200 status code because it's working. We can access the resource, or rather the page itself. You have 201, which is created. So a new resource, when you're using post, for example, and you want to create a resource, this is what you're expecting to get. So you're expecting to get 201, that your resource was created. And then if you want to double check, you can use get, and you can check whether it says okay, and it shows you the data for the resource that it exists. We also have 204, no content, that the request is successful, but there is no information, no new information to send back. So if you don't update something, you try to see whether it's modified and nothing has changed, everything is the same, you can actually see such information. Moving on, we have 3xs, which is redirection. So this indicates that some resource is uh, basically changed from where it was to a different location, or that you need to do some additional steps to complete the request. So uh, this is most common. So when you've had a resource or a page that you were using quite frequently, and let's say it has been moved to a different URL. So when that is done, you usually would get this information that it was moved to a different location, like 301, moved permanently. So requested resource has been permanently moved to a new location. So you might see this on pages as essentially as like a let's call it a dialog box, and it will provide information that is the resource is moved, and you will usually have a link to where the resource is now. This is especially common for some pages that you use quite frequently. And then we have 302 found or 307 temporary redirect. The requested resource is temporarily located at a different URI. You won't come across these that often because usually what is done is so that people do not see these, let's call them placeholder pages, so we don't want to actually showcase these to clients or users most of the time, but there are specific scenarios that do require them. So maybe something needed to be changed on the page, or it's actually being worked on, so you will see a 307 on that page, and maybe some interesting graphic that shows a construction on the page that redirects you for the time being. And then once everything is set, you will be able to access the resource on that URL. Moving on, the one that most of you are aware of, and most of us actually are aware of and have seen multiple times, are the client errors that start with a 4. So they indicate that there is some kind of issue on the client side. So it's not something related to the application. The application is running, the pages are good, everything is okay. It is something related to us as clients, meaning we are maybe unauthorized, so we're forbidden of accessing the resource. Maybe we missed something in the URL, so we cannot, the resource does not exist, or we have a bad request. So for a the status code for 100 is bad request, so the request was bad or it is missing some parameters. So basically, when you are trying to access some URL, but you are not at all adding a very important parameter within the URL, so you're not trying to add the, let's say, a directory in it, you'll most likely get the bad request because that is not something that the API expects you to send. 401 unauthorized. This is something that you have to have credentials and a valid token for. So you have to be authenticated to access it. And a good example for 401 is usually when you're working with some company resources and you're starting off fresh. You usually need to have specific roles assigned to you, or you need to have permission granted for resources. Let's say for Confluence, Jira, and when you try to open them at first, you'll usually see Jira has this default layout, and it says 401 unauthorized, you need to request the admin for permission. Usually it will say something like that. So this is the most case when you will see these unauthorized messages when you try to look up on some practical examples. And then we have 404 not found. Plenty of us have been there. We might have missed the URL character. We might have written something completely wrong when trying to fetch a resource. And this is the most common client error. So we can't find the resource because we might have missed something when trying to find it. Moving on to the last type of status codes, which is the server error status codes that start with 5. And these are essentially related to issues with the server or the application in general. So this is usually when there is some kind of big issue, maintenance, downtime, or whatever can be related to the application's performance and functioning, you will usually see this error. So this indicates that there is an error with the application itself. And I saw Valentina wrote 500 bad requests very often in Amazon tools I used. Wonderful, great example. So 500 is an internal server error. So there is an unexpected condition. So this could be due to a multitude of reasons. So there could be an app crash. There could be some function that managed to put down some specific services. So you can actually see, you can actually not use anything from the application due to some issue that occurred. And when we see these types of error codes, it usually means that there is a big issue and it has to be covered ASAP. So when it's server related, it has to be addressed ASAP. Then we have 503, service unavailable. the server is not ready to handle the request. Now, the difference between these two is like 500 can be related to to a crash, so nothing is working. 503 actually means sometimes that it could be working, so it is functional, it is up, but it might not be handling load for all users. So it could be an issue where maybe 1 million users are trying to use, let's say, Ticketmaster to buy tickets, and some users, not all, but some, will get a 503 service unavailable. And that's because it is crashing for some of them because of the large number of users accessing it. And when you will do some load testing, we will have a lesson for this, um, the most common code that you will see when there are issues is 503. So when you see 503, you might also see 504, so gateway timeout. These are the ones that you will see because the service will be unavailable for some users. Some will see it, some will not, and this is the error which we also want to avoid. And that's why we do non-functional testing. So we want to avoid a scenario where some users can access, some cannot, and they receive a server error. And is usually mitigated with scaling up environments, which we will talk about in due time. Do any of you have any questions regarding the status codes? If there are no questions, I'll leave a bit more room if somebody wants to ask, and I want to add something. Again, related to interviews and remembering these bits, it's very important to remember the server error and the client error as well as the success messages. So you don't need to remember everything from 200 to 209, so you don't need to remember all codes by heart, but it's good to remember what they do. So if it's 200, it is a success message. If it is 400 something, it is a client error. If it's 500, it's a server error. This is a common question, and sometimes you could actually be questioned about what does 400 mean? What does 404 mean? When does it appear? So usually the ones that you see listed here are more than enough for you to be prepared for when you have some interviews. But keep in mind this, especially for beginner testers, this is a must know. So this question almost always appears, and it's good to know the difference between the status codes. Okay, I don't see any questions so far, so I'll move on to the last bit, which is the HTTP response, header and body. Let me just see. So Valentina wrote, why if 404 is client, but the resource could not be found is the cause? Shouldn't it be related to the web page? Well, this is a very good question. If it is a scenario where you get 404 as a client, but the resource cannot be found is the cause. So let's say it's a server error or something, then that is a huge bug. That is a very crucial bug. I won't say it's common because usually these types of status codes are fairly straightforward and automated in the system. But if you get a client error for a server, then I mean, it should not be possible, but um, uh, I see. So I remember when we developed e-commerce, we set the 404 error message if any page were dismissed at any point. Uh-huh. Um, we set the form message if any page were dismissed at any point. The idea behind it is so if yeah, so I mean if you do this in a way, you're technically when you show this, you're indicating that there is an issue on the client side when it actually could be an issue on the server side. And this is a bit misleading. I mean, this is usually not the way to go about it. But if there is such a setting, and if there is maybe even some mistake when working with the status codes that need to be sent for specific issues, this would be counted as a crucial and high importance issue. So this will need to be fixed ASAP. Me personally, I have never come across such a scenario. Usually, when I get the client related status code, it's usually something that I have messed up. But if it is a client code for a server related issue, yeah, this client is the web page. And uh, if I get this issue that is on my side, but it's actually the server, then that is a crucial bug and has to be modified. It must never be uh, shown to the public. Yeah. All right. yeah, let's finish up with this last bit with the responses. So as I mentioned, similar to the request, we have response header and body. The headers provide additional info similar to the request, and they are also included in the HTTP response below the status code as we saw before. They have the same information that the request header has. So we have the content type. So we have what kind of data we will be sent within the body. Most of the time, as we said, is JSON. We have the length. So what is the size of the response body? It's usually in bytes, and you know how much data you can expect. And then the server identifies the software or the technology that handles the requests. If you use Apache, it will show server Apache that is the one that will be servicing the request. Again, this depends on what type of server will be used to handle this. Again, it's useful to note down for when you're testing something and you find an issue, so the developers know where the issue is arising, what might the application or the server handling the request be, so they can catch the issue a lot more easier, or you can replicate it. But these are, again, more or less additional information for the response. And then the body is basically whatever you have related to the resource that you request from the server. So everything that is stored as data there, you will receive in the body. And the data in the body can be in different formats, as you mentioned. It can be JSON, it can be XML, it can be also HTML. So um, common preference is JSON because it is the simplest, it is the easiest to read, it is the easiest to understand. It basically divides everything very well in a structured manner. XML is a bit more complicated, so you might have a bit more details that you don't really need to read about, and you might find it harder to find the information that you need within the XML. And then HTML, while it is simple to, it is similar in a way to the XML. Uh, this usually is not that common of a practice because usually you want HTML files to essentially kind of like open up a web page, like a local web page, and to see some reporting in them, but they're not very useful, I would say, for receiving data from a response from some server. Additionally, the response body may contain binary data like images, videos, or non-textual content, and this usually is specified in the content type. So if you have some video, if you have some images, like we previously mentioned in the request example, so a profile image that that you have uploaded is present on our Facebook profile. So when you try to get it, it will be specified in the content type that is also included, and you might see a path inside as well. And then error messages in the case where we have 4xx or 5xx status messages, the response body can contain some additional information about the nature of the error. So it could say uh, bad request, it could say gateway timeout, it could say resource moved. So if there is some kind of issue with the API and the endpoint itself, you will usually get information in the body, and it's usually just textual information regarding the status code that you got. And it's quite common. We will also see it in the exercise, how it looks like when you receive such an error message. And I think that will be more or less everything regarding the REST API. So how the request works, how the response works. I will just trace back briefly and say, so we as a client from the web page, we want to send a request to fetch some kind of resource from the server that in the response will send us the response that we need with the data that we want. If we, of course, are authorized and can see it, and then that goes back to us, and we're able to execute any operation that we as users need. And that is more or less everything regarding the how a cycle of REST API functions. Do we have any questions regarding this? If no additional questions related to this, we're going to go into the lab testing exercise. So note, for today, we're just going to do a brief, let's say lab, just to kind of skim through some of the concepts that we learned. We're not going to go too much into detail of posting and deleting too many requests today because we have a lecture dedicated to that, and we're going to play around a bit with Postman that bit. So for today, we're going to use Hopscotch. which is an open source API development and testing platform. And essentially, it can be used for checking briefly what some endpoints sent as a response to us, what we can send as a request, and its primary use is for development debugging, but we can also use it sometimes to do brief validations. Um, I would say it's not ideal to use on projects. So oftentimes even hopscotch is not even allowed to be used on projects. So you usually use Postman for that. This is more or less as a learning tool. So you can use some public APIs to play around with it. And you can see what it shows as response. So I would even say this is more or less used for learning in a way, so that you can kind of get a feel for how you can send and receive requests and responses respectively. So without further ado, I'm going to open the Hopscotch API testing development tool here. I'm going to briefly show you what we can see here. So when you use Hopscotch, you will see this is the layout, and this is the same, not the same, but a very similar layout to Postman. Some of you might have used it. So what you can see here is that we have the type of HTTP method. So we have a lot. We have get, post, put, patch, delete, head, options. For the time being, we're probably going to stay with get in the interest of time for today, because again, we will have a dedicated lecture to work with different methods. So you can choose the method here. You have a specific, you have an input field where you can insert the URL for which you're trying to reach and get a resource from. You have send here that you can send the specific request to that URI. You can also save it. And then here we have some parameters. If we need to add some variables, you have a body. Unfortunately, here you have to upload the body. So you don't really get to write it here, which is unfortunate, but we won't be needing it for today. We have some headers which we can use. We have authorization where we can add tokens if needed. We have pre-request scripts and post-request scripts. So again, these are things that, again, we will tackle a bit more in detail in the next lecture. So you don't get too confused about all the things that you can do with these API testing tools. So without further ado, I'm gonna move now into the exercise. So we have the REST countries API. We will be testing a bit some of the responses that this API does. What the REST countries API is, it is a free and public web service that gives us information about countries and territories around the world. We can open it on the link here. And it has a brief documentation of everything that we will need. So we will need to see a bit, skim through a bit of the documentation so we understand what we can do and work with within the API and what endpoints we have available, as well as some operations. Now, what we will be doing, we're going to do some exercises. We have a few requests that we will need to perform here below. Yeah, let's dive right into it. So the first that we want to do is to use a get request for all countries. So I want to list all countries. So I'm not going to open up the answer yet. What we need to do now. So before we start writing the request, so we obviously need to find out what is the URL. So we cannot just go in here and copy, for example, this all without knowing the full URL. So for that purpose, we're going to go to the REST countries API documentation. And one single note, this might not be the cleanest documentation. Again, this is a public API. Most public APIs have a similar documentation, so you might see not a lot of good layouts hanging around, but they do the job. They have everything you need, and they give all the information. So when trying to test specific APIs, it's very important to open the documentation. So you'll want to read a bit what you will need to check, what you can expect as a check. So you usually just go through that in the documentation. So we see about this project that is inspired some uh, REST Countries EU by Feder Flores, and some information is added for that. So in the interest of time for today, we're going to just see what we need and how we can test it. So if I go back to the materials, we see we need to get all countries. Knowing that, we can see on the left side, we have a lot of information provided and we see all. So I'm just going to go to all and see what we have here. You must specify the fields you need, up to 10 fields when calling all endpoints. Otherwise, you'll get a bad request response. Please see this issue for more information. This applies to all versions. Okay, so we see for the all, you must specify the fields you need, up to 10 fields when calling the all endpoints. So if we follow that, we will probably do some modifications to the URL, but first on the right side, we have the URL that we need. So we have the https restcountries.com version and then all. So I'm just going to copy this entirely. And now if I go here and just paste this, so this is all the reading I did at this point for the documentation. So I just read, okay, I need some fields, but I see the API, the URL that I need to add here. So I'm just going to copy and paste it. So what happens? Let's see what happens when I just do this. We see that I get a bad request. So 400, bad request message. Fields, query not specified, status 400. So this was something that we talked about in the response. So when you have a bad response, in this case a 400, it does send a body, and the body only contains the status and also a message. So we see here it says message fields not specified. So if I go back here, I see that says you must specify the fields you need, up to 10 fields. And because here we don't see that, so we don't have any additional instructions how it looks like, we usually want to click on the links that are provided here. So extra documentation. Let's say I don't know how to add the fields. So I'm a newbie, I'm still learning. You can open up the links here and you can do a bit more reading within this repository granted here. Now, when you scroll down a bit, you will notice here, this gives you all the countries by name. So I see I have the same URL that we used previously. So this is the URL that we used. But in addition to that, we add a field. So I see, okay, this is what I need. So if I go back to Hopscotch, I can just copy this bit here, go to Hopscotch. And then, as you can see, I just paste this section field name. And now we have added the field that we were requested to do in the API. So now, if I do this, modify it like so, and send, we see that we get a status 200, which is okay. We get the time, get the size, and now we see all of the data displayed in the body. So we have the name, which is the field that we specified, and we have what that field contains. So we can see it has the object name contains common, so something like Jamaica, official, maybe this is the official language, Jamaica, native name. So this is a sub object within it. It has some language information maybe. So we see a lot of information provided to us just from adding this field. And we see that maybe this is not the entire information of the data at the endpoint. However, we added the field that we needed, and now we can see what is the data that we get. Now, if you want to make this a bit more rich, so you don't want to use only one field, what you can do is you can actually just add a comma here, and then you can write down languages. Now, in the interest of time, I'm not gonna go too much into the documentation so we can cover other scenarios. I'm just gonna write one more field here, and I'm gonna use capital as well. So here we go. It's something I tried previously. And if I do this, now we will notice when I send it, I have the name, I have a capital now. So I have also the capital object. And then I also have the languages that are spoken. So I have English and Jamaican Patois. So we have both languages displayed. We have the capital and the name. So now I'm using fields. And we can actually add up to 10 fields here if you want, in order to see more data from the API. I see a question from Binu. Could you explain after entering all countries field to the current one? I had some issues with my headphone. Yeah, of course. So I'm going to explain why I did what I did here. So this is a neat trick, and I'm not going to go too much into detail. We're going to also talk about this in the next lecture. I don't want to confuse you too much and overwhelm you at this point. So why did I add the question mark? So what happened when I said when I send only all. So when I do not add this specific part here, the query doesn't work. So the URL will not send anything. It will send a bad request. Now, when I went into the documentation, it said you must specify the fields you need. So I need to specify the fields. Now the fields you don't specify within the body, you just specify them here in the URL. And the way you specify them is, this is the URL. So what we see now, this is just the plain URL. And if you want to specify the field, it is the same as specifying this, what you see here, but you add it in the URL. How can you add it? The special delimiter, the question mark, means that you will add a query. You would add some query into the URL. And what is that query? Well, I would like to add a field, and I'm going to add a name to that field, which is going to be, it's actually fields, which is going to be name. So where do I get this field name? Well, this was from the documentation that I have here. So they probably have some kind of list of fields that you can use. The three I found were languages, name, and capital. And the way that you work is the way I just showcased. So you add a question mark to say that you're going to add some query, and then that query will be by fields. So we're going to try and find resources that contain the fields name, languages that I added, capital. So you're essentially just listing fields that you want to use. So you want to use the name, you want to use the languages, you want to use the capital, maybe there is currency. I'd not really do too much in-depth research because there are many fields that you can use, but they're usually listed in the documentation. So what I just do is just use the standard URL, add the query delimiter, and then add the field that I want, or add the basically the item which I want to query. In this case, fields. And this is the only one that I can use for this API. So I tried other things that I looked up, but this is the only one that will work for now. And this information actually you can find in the documentation. So this is not something that you learn or know from, let's say, a vast programming knowledge that you need to have. This is just opening the documentation, reading through it, and seeing how you can make use of it. One thing I wanted to show as well is the headers. So if I go into the headers field here, we will see they have cache control, so public, immutable. We see some additional information. Content length is 65,158, so we have a lot of data that we want to showcase, and the content type is JSON, as we see here. So this is essentially what you can expect from a standard API test. Usually you won't have so much data, so you don't want to really list too much stuff. You're not going to test on a batch of 60,000 bytes of data. You're most likely going to test segments, but in a nutshell, this is what you will see. Now moving on, let's try another request. So we have a GET request for a specific country. So we need to choose a country of interest and make a GET request to it. So we just want to see one country. So let's see how we can do that. So we just used all at this time. And now we see right below it, you can search by country name. If you want to get an exact match, so an exact country, use the next endpoint. It can be the common or official value. So we see this is the API, the URL that we will need to use. So we have the same URL up to here, and then we have name. This is one parameter that we add, and then we write down what is the name of the actual country. For example, we have here name ST, and then we have name Deutschland. So you can choose however you want to go about it. I'm just going to copy paste the last example that we have here because it's already there, and I'm just going to replace it here. So now I have added the parameter that I need, which is the name and the name of the country. And if I click send, this should return everything about Germany. So we have the name, common Germany, official Federal Republic of Germany. We have some information about the Bundesrepublik, about the other names. I'm not very versed with all this information. We have some codes here. So DE, one you can also see on registration plates as well. You get the short abbreviation here. You have some status here. You have whether it is a UN member. So we see all this data, the currency as well. So everything provided in the JSON file. And if we go to the headers, we see we have now a different amount of content length because obviously we have only one specific selection made here, and it should be less than what we had previously. Now, it's important to note um, when writing when trying to find some information documentation. So for example, previously I only found the fields that we mentioned, so we added the name. Sometimes if you want to find more information about an API, you can actually just generate a call, a general call, or this call that we did here, for example, for the country. And if you see, I have the name, we have the fields here. So we have the name, and then if you scroll down a bit, you can also find additional fields. So all of these are separate fields. So we can actually even try to use these fields when trying to select all the countries. We can use the name, we can use TLD, we can use IDD. So we can use different, we can use capital that we already did. We can use region, sub-region. So you can use all these fields up here if you want to get more information. And you can actually get more information by simply executing a single call if you find it hard to do it in the documentation itself. So we can try another country. For example, I'm going to try, let's do Canada. If I try Canada, will I get a correct response? We see now that I get common Canada, so now everything is related to that. If I open the headers, I have less content length, and this could be to a multitude of reasons. So maybe I have shorter zip codes, maybe some information provided is not the same as we had with Germany. So we see this also changed. All right, let's move to another request. So we have this request, which is get request for country by currency. Select a common currency and use a get request on the currency to find countries using the currency. It's pretty straightforward. So let's see if we have here something listed about currency. We have search by currency code or name. So we have the option to do it here. So we see what is the URL, currency code. So let's copy this. I'm going to paste it here. So again, previously we had name, we wrote the name of the countries. Now we write the currency and we write what is the currency value. And if I do send and I scroll a bit above, we see Colombian pesos is related to Colombia. So we get the country that uses this currency. Again, we have the same information that we viewed before. No need to go too much about it, but essentially we are getting everything we need from the request that we made. And you can notice that due to us specifying the currency, we have a shorter amount of time needed to get this because maybe this is only one country that we get, similar to before. We have the code here, the content length here. We have all the information same as before. And you can also use the JSON and the raw here if you want, but I mean, I think the general preference is using the JSON. So you can see we're essentially just using endpoints and trying to get some kind of data located on them using the get method. I believe we have one more request, which is request for country by region. So pick a region and make a get request to the region name to get a list of country in that region. Okay. So let's see if we have something regarding regions here. There it is. So search by region, replace X with the version you want to use. Okay, we don't see any X here. So this is probably just outdated. So I'm gonna copy again this URL here because we already have the region provided. I'm gonna paste it here. And let's send and see what the region returns. We see again, everything is okay, working as expected. And then we have countries listed in the region. Now, when you would be doing a more detailed testing, you're going to probably go through all of the countries that are listed here. You're probably gonna do a bit more specific query. We see here North Macedonia. So again, this is part of Europe. We see if we scroll down a bit, let's continue on here. It has some information about on Google Maps. We see Latvia, so we see countries that are listed. Usually when you will be testing these items, you will have a checklist. You will compare whether the checklist matches that what you get in the data. So whether in Europe, if you get Colombia, for example, that does need to be there. So there needs to be a modification in the code, the API, wherever it may be. And that is usually what you will be looking for when you do such requests. Again, this is a bit more low level. This is not something that we're, uh, let's say, doing quite often. So you will do these get methods, but again, you'll usually have some kind of checklist. You will usually need to expect some values to appear here. They will not be as large as we have here. For example, now we have 173,000 values here. But yeah, there will be more specific and catered to some endpoints. Do you have any questions so far? I know it's a bit more than expected information, especially for jumping into this, but I promise it really does get a bit more clear once we do a bit more testing, a bit more experimenting with tools like this, and you will get a better idea of how all this works. So, okay. If there are no questions, I'm just gonna um, let me get let me find the correct there we go. Okay, so we're just gonna move into the conclusion if there are no questions because I don't see anything rising here. So what I want you all to take away from today's lecture is what an API is. So we talked a bit about it. It is essentially something that connects applications and system together as well as with the users, and it has some set of instructions on how to use resources on it and what to expect, or rather which operations you can perform and what outcomes you can expect. There are different types. You have public APIs that all of us can access. We have private APIs related to organizations, and then we have partnered ones, which are usually within specific teams or individuals that can access it for specific needs, as well as some close ones that you can composite APIs, which you can use one call to essentially just get multiple data response items from it. We also talked a bit about the JSON format, so that that is lightweight. It's the most commonly used one for sending requests, receiving response, and basically interchanging data between the applications due to its lightweight, due to its ability to be used in different programming languages, as well as to essentially just how to put it, um, being so compact and fast, and making it very neat to use. Also, we talked about REST APIs. So how does it function? We have the server, we have the client, we have the resources and the API, and the communication between it. We have requests that are sent by the client, processed by the API, sent to the server. The resource is on the server, it is fetched, it is sent in a response from the server based on whether the request is valid or not, and then an appropriate status code is sent to the user indicating whether everything is okay with the resource, or if they can access it or not, or even if the application is down. Um, I see one more question here. Please, where will the API question be placed when coding answers? Um, uh, mm, sorry, Daniel, can you rephrase the question, or is it related to the uh, test case? Just want to double check. I see nothing here. I see. So this is where this is related to the question. Thank you very much, Serafim, for answering that. Okay, then if you don't have any related questions to APIs, so you can still ask me anything related to APIs in general, API testing, so whatever is of interest right now. Do you have any questions, anything specific for any part of the lecture for now? If not, then that will be all from my side. So I would like to thank you all for the attention